Welcome to homework.
Okay, so we have a list of substances that we have to classify. The first one is hydrogen. Now, recall that hydrogen exists in nature as a diatomic gas. That's two atoms of hydrogen bound together. That's how it exists, unless it's been incorporated into some other molecule. For that reason, we consider it to be a molecular element. And what I mean by that is if we have hydrogen, it exists as two atoms of hydrogen bonded together. Okay, we could also draw it like this. So this is a molecular element. And this is in contrast to something like neon. Okay, neon does not exist as a diatomic or a triatomic. If we have neon, say in a flask or in a balloon, the neon exists as single solitary atoms of neon floating around. There's no two neons bonded together or anything like that, right? Neon simply exists as individual atoms of neon, and that's why we call it an atomic element, right? Single atoms. Molecular element, multiple atoms in its natural state. Atomic element, single atoms in its natural state. So that's what's meant by that. Next, we have sodium chloride. Now, if you recall, sodium chloride exists as a lattice of sodium plus ions and Cl minus ions that repeats nearly infinitely on an atomic scale, right? So if we were to draw a picture of sodium chloride as it exists in, say, table salt, it's actually going to be crystals. Right? Something like this. Like, oh, there's some sodium. Okay. And then we've got our chloride. Oh, wrong color. Chloride ions. Right? Um, okay. So it's a repeating structure of atoms all joined together, and they're all in an ionic form. Okay. So this is what we call an ionic compound. Okay, and our next example is CO2. And this is actually the next type of thing that we have. This is a molecular compound. What's meant by that? Well, the picture of CO2 is carbon. Well, let me draw it like this. A different color. Okay, here the carbon's shown in black and the oxygen shown in red. This is what CO2 looks like. They're discrete molecules of carbon bound to oxygen, right? So if you have CO2 in a flask or a balloon, it's a bunch of individual molecules floating around. They're not ions, they're covalently bonded to each other, right? So it's different than sodium chloride. Also, you have a bunch of discrete molecules floating around instead of a repeating lattice in some sort of solid or what have you, right? So CO2 is a molecular compound. And we can go through the rest of these. N2O3 is also a molecular compound. Okay, iron oxide. Okay, this is an ionic compound. Okay, calcium. So calcium is just a solid metal, right? So it's like a bunch of calcium atoms floating around in a solid, right? But you'll note only calcium is present, right? So this is a molecular compound. right? It's forming a large network, molecular compound, molecular element, right? Only calcium is present, but there are multiple atoms of calcium present in its natural state. So it's similar to neon, except for instead of individual atoms floating around, not similar to neon, similar to hydrogen, but instead of discrete units of two floating around, but everything's hydrogen, it's a large network of a bunch of calcium atoms, right? So it's sort of like sodium chloride, but we don't have a mixture of different ions. We just have calcium. And finally, we have chlorine, right? Chlorine exists just like hydrogen as two chlorine atoms bound together, right? Or we could say Cl bonded to Cl, right? So this is another molecular element.